So, hi, the topic of today will be about inequalities. So, inequalities are part of life. You can easily think about some situation in your life that you had to sell or buy something. Each of this time you had to do some kind of evaluation. What is the cost of this object and what is the benefits? And often when you're dealing with such situation and there is a gap that is too big between these two, you can either be happy or sad. Like in this example, if somebody tries to buy something half of the price, you will be frustrated because he's cutting down on the benefits that you get from selling this object. So each time that you have to deal with trading, you have inequalities. So let's look at the definition of an inequality. So in mathematics, an inequality is a statement allowing to compare the size or the order of two objects. So here in this video we consider the set of real numbers, and the fact is that this set is an ordered set which is measurable. If I give you two different numbers, there is a order relationship between these two numbers. One is bigger than the other or they're equal. Now let's look at the notation. So here you have different case. You have like strict inequality and regular inequality, which are on the large sense of inequality. So here we have a strict inequality. A is smaller than B means that A is strictly inferior to B. A is greater than B means that A is strictly superior to B. So these are strict inequalities. A smaller or equal to B mean that A is strictly inferior or equal to B. This is a large sense inequality. And then you have A is greater or equal to B, mean that A is strictly inferior or equal to B. Let's look at an example of an inequality. Let's consider A is equal to 2 and B is equal to 3. So here you can put 2 and then it will be at the position 2. Here there is an arrow which only symbolizes that is starting from 0. Here you have B which starts at 0 and then goes to 3. And then what you see is that 2 is at the left of 3. The green dot is on the left side of the red dot. So A is smaller than B in this case. Now an example of an equality. Here A is equal to 3, B is equal to 3. So here you can draw A. It's on the position 3 on the real number axis. And then where is B? Well, B is on the same place, so they're overlapping on the position 3. So in this case we have that A is equal to B. Last case, A is greater than B. Let's set A is equal to 3 and B is equal to 2. Then again, A is equal to 3, we put it at position 3 on the real axis. This is the green dot, and then we do the same thing for B, so it becomes the red dot here at position 2. And then you can see that the green dot is on the right side of the red dot, which means that A is greater than B. So we will take a look at two essential properties of inequalities, and then later on we'll work on some new ones. So the first one is about what we just saw earlier. So for all x, y in the real number, one and only one of the following three possibilities is realized. So we saw that earlier with the three possibilities that we saw on the real number axis. And then for the second one, for all x, y, and z in the real number, x greater than y and y greater than z imply x greater than z. So this scene is the key of the video, and it's really a powerful theorem. If you understand this theorem, then you have understood everything that I want to teach in this video. So this is about applying a function to an inequality. So any strictly increasing function f, which map from the real number to the real number, can be applied to both terms of an inequality while maintaining it. So if you have a greater than b, then if you apply f on both sides of the inequality, then you see that the sign of the inequality doesn't change. And similar on the opposite side, if you have a strictly decreasing function, then if you apply the inequality, then the sign just flips sides. So if you have a greater than b, it becomes f of a is smaller than f of b. So now let's work with a simple example of the first case of the theorem. So consider f of x equal to x. This is a strictly increasing function, okay? Then what we are going to do is to set a and b to different values. So here a is equal to 1, so this is purely arbitrary value, and then we have b is greater than a, so this is kind of a free variable. So now what you have as a relationship is that a is smaller than b. Then if you plug these value inside a function, then what you get is you get f of a and f of b. And then you said if you increase b, you maintain the inequality. So a is still smaller than b, but at the same time f of b is always greater than f of a. So this is for the first case. So as an exercise, I recommend you to practice to do the same thing with f of x equal minus x and try to see what happens. So remember, these are simple functions, and this can be done with any function if it is strictly increasing or strictly decreasing. So here are some particular cases that are really useful to solve inequality with respect to one or multiple variables. So here the first case corresponds to f of x is equal to x plus c. So if you have a is greater than b, you apply the function f on both sides of the equation, and then because x plus c is an increasing function, the sign of the inequality doesn't become the opposite, so it's conserved. Similarly for f of x equal x minus c, this is an increasing function, so same principle, so you can apply the function on both sides of the inequality without having to change the sign. And then finally for the last case, cx is a little bit more tricky because based on the sign of c, the function is either an increasing function or a decreasing function. So here if you have c is greater than 0, what happens is that it's an increasing function, the sign of inequality stays the same, and if c is smaller than 0, then it's a decreasing function, and then you have to flip the sign of the inequality. So now we'll work with an inequality in which we have to solve with respect to a variable. So think of it like an equation but for an inequality. So an inequality can become true or false depending on the value of the variable. So now let's solve an inequality with respect to a variable. So we will work with the following inequality. So 3x is greater than 2x minus 3. So is this inequality respected when x is equal to minus 4? What about for x is equal to 0? So we have two cases to check. Case is x is equal to minus 4 and case x is equal to 0. So what we do is that we evaluate both sides of the inequality, and then we check if the inequality is respected. So for the first side, 3 times minus 4 equal to minus 12, and then for the right side, 2 times minus 4 minus 3 is equal to minus 11. So minus 12 is not greater than minus 11. So it's false, the inequality is not respected when x is equal to minus 4. Now what about for x is equal to 0? So same principle, left side of the equation, 3 times 0 is equal to 0. Right side, 2 times 0 minus 3 is equal to minus 3. So the question is 0 greater than minus 3? Yes, so the inequality is respected for x is equal to 0. So now it's time to solve the inequality with respect to a variable. Now let's do it. So what we want to do is to find a set of solutions that respect this inequality. 3 minus 2x is smaller than x plus 9. So pause the video and find the solutions of this inequation. So the solution is all the value of x which are greater than minus 2. So if you didn't find it, no problem, we will check this out in the next scene. Now let's find the solutions of this inequality. So we do the same thing as we do with an equation. So we put the variable on one side, and on the other side we put the constant. So here we'll put the x variable on the left and the constant on the right side. So what you're doing is that you're simply writing this expression by putting minus x on the left side and minus 3 on the right side. So you get minus 3x is smaller than 6. Then you can divide by minus 3 on both sides of the inequality, and then you get that x is greater than minus 2. So feel free to use whichever notation you want to use. You can use the set notation or the interval notation. So here are some additional exercises that I recommend you to do to practice these manipulations. So I will provide you the solution for both of them, but I recommend you to try to do it by yourself before checking the solution. So here you have two inequalities. So I recommend you to pause the video and then try to find the solutions for each one. So here the solution are respectively x is element of the empty set, so there are no solution for the first inequality, and for the second one x is between minus 5 and 39.